Today we're going to deal with parallelograms, and we've got a couple examples involving parallelograms, and this is the takeaway of what I want you to know how to do today. I want you to know the properties of parallelograms. So when you see something's described as a parallelogram, you immediately know these 5 things exist. The definition of parallelogram is a parallelogram is a quadrilateral with opposite sides parallel. So this first property is just based on the definition of parallelogram. The rest of the properties are theorems associated with parallelograms, but they're true also. So the opposite sides are not only parallel, but they're also congruent, meaning they're equal to each other. And when I say opposite sides, I think you guys know what I mean, but let me just verify. That's a parallelogram. So the opposite sides will be the ones across from each other. So property 1 tells me this is parallel to this. Property 2 tells me this is congruent to this, that's congruent to that. Property 3, opposite angles are congruent. If I'm talking about this angle, I go across the parallelogram, that's opposite. This angle, go across the parallelogram, that's opposite. That's what that one tells me. For property 4, if we call this parallelogram ABCD, it tells me measure of angle A plus measure of angle B is 180. Measure of angle B plus measure of angle C is 180. Measure of angle C plus measure of angle D is 180. And measure of angle D plus measure of angle A is 180. In general, if I'm at any angle, I go to the next angle over, those light up to 180. 1 cubed plus 1 obtuse equals 180. And finally, the diagonals, if there are any diagonals, let's draw some diagonals in this thing. So diagonal AC and diagonal BD, those diagonals bisect each other, which means they cut each other in half. So this piece is the same as this piece, and this piece is the same as this piece. This right here is the midpoint. Let's call that E. E is the midpoint of both diagonals. All right? So in other words, when you get the words, something is a parallelogram, they're opening up a whole bunch of specific properties that can be used to create equations. Those equations then be solved to find whatever the missing measure is that you're dealing with. So, example 1, quadrilateral Pqrs is a parallelogram. So again, they're telling you that's a parallelogram, so immediately all those properties we just saw a moment ago, all these properties here are alive and well in that parallelogram. There are no diagonals drawn, there's no angles marked, so the only thing I can deal with is the opposite side and opposite side stuff. So these are the only 2 properties that are going to come into play on this one. All right, opposite sides are parallel, opposite sides congruent. I'm trying to find the measure of x and the perimeter of PQRS. So in order to find perimeter, I need to know the length of each side. So looking at this picture, I know opposite sides congruent. So I know that either 7x minus 3 is equal to 2x plus 12, or 4x equals 5x minus 3. Either pair of opposite sides is congruent, so I can use either one of those pairs of opposite sides to create an equation based on that property. You can pick and choose which one you find to be easier. I don't care, it doesn't matter, they'll both get you the right answer. Let's just pretend that this is the one we consider to be the easiest equation. 7x minus 3 equals 2x plus 12. I'm going to chop the 2x, move it over here to the 7x side, chop the negative 3, move it over here to the positive 12 side. This move became negative, this move became positive. Signs change when you change sides. 7x minus 2x makes positive 5x. Subtract because the signs are different, positive because 7 is bigger. 12 and 3 makes 15. Add because the signs are the same. positive because 12 is bigger. Divide both sides by 5 to get rid of the coefficient. That gets me x equals 3. So part A, what is the value of x? X equals 3. How do I solve this equation instead? Maybe I move the 5x to the left. 4x minus 5x is negative 1x. Divide both sides by negative 1, we get x equals 3. And it doesn't matter how you go about doing it, x should equal 3 based on the property. Opposite sides are congruent. So part A is done when x equals 3. Part B says, what is the perimeter of Pqrs? Well, what do we need for perimeter? What do we need to know to find the perimeter of a figure?
All sides added up.
Oh, so we need to know the length of all sides, right? So currently we don't know any sides. We got sides of 7x minus 3, 5x minus 3, 2x plus 12, and 4x. Those aren't numbers, those are just algebraic expressions. But since x equals 3, 4 times 3 is equal to 12. 7 times 3 is 21. 21 minus 3 is equal to 18. Opposite sides congruent, so this should also be 12, but we can verify 15 minus 3 makes 12. That's correct. Again, x equals 3 times 5, 15 minus 3. This should be 18. 2 times 3 is 6. 6 plus 12 is 18, so that gets us there. So we know the length of every side now, so perimeter is simply the sum of those 4 numbers. So perimeter is going to be 12 plus 18 plus 12 plus 18. 12 plus 18 is 30, plus 30 makes 60. So the perimeter of this parallelogram is 60.